Part 2, number 13. A particle moves along a horizontal line with position equation S of t, which is equal to 3t minus 2 and t minus 5, with S of t measured in feet and t is measured in seconds, with t is greater than or equal to 0. So here my position equation is given to me. I'm going to actually simplify it. If I double distribute it, I do get 3t squared minus 17t plus 10, right? So part A is asking me what is the initial position of the particle. Initial position means when my time or t is equal to 0. So basically I'm going to find S of 0, which would be actually 10, right? Because everything else becomes 0, so 10 feet. Part B, it's asking you for particles displacement. Displacement is basically how far you got from point A to point B. So it's S of B minus S of A. So it would be S of B is what? First 4 seconds. So it'll be S of 4 minus S of 0. S of 4 is, if I substitute in 4, I get negative 10 minus 10. S of 0 is 10 equals negative 20 feet, which means what? You're moving to the left. The negative just, you displace 20 units or 20 feet, but negative tells you you're moving to the left. Part C. When does the particle change direction? So particle changes direction when my velocity changes sign, right? I always start again with my justification that helps me get the answer. So I don't know my velocity equation. So first let's find the velocity, which is the first derivative of my position, which would be 6t minus 17. So I'm going to set it equal to 0. So t is equal to 17 over 6. I'm going to do my velocity number line. This is my velocity number line. I'm starting at 0. And my other number is 17 over 6. So I'm going to pick a number from each interval. This is 17 over 6 is 2 point something. So this would be what? Let's say pick 1. If I pick 1, I end up with a negative here. And if I pick a number greater than 2.1, oh, it's negative. I do get a positive number here. Let's say I pick 3. 6 times 3 is 18 minus 17 is positive. So it's changing signs at t equals 17. You must always check with your number line because not necessarily the signs always change, so you must check them. Okay, D is asking me the particle's average velocity during the first 4 seconds. So if I want to find average velocity of my particle, it's going to be S of 4 minus S of 0 over 4 minus 0. We already did S of 4 minus S of 0, which is negative 20 in part B, over 4, which is negative 5 feet per second. Right? Okay. So basically, what does that mean? The position is decreasing at a rate of 5 feet per second. It's decreasing because it's a negative. Okay? I know it's not asking you to explain that, but I just want to give you the explanation because it makes you understand this better. Now, what is the particle's acceleration at t equals 2? First of all, I need to find my a of t, which is the derivative of my velocity, which is just 6. So a of 2 would be also 6 feet per second square. So it's going to be always 6 feet per second square, right? Because it's a constant. So the next question, you can use the calculator here for this question. It's saying a position of a particle in inches moving along the x-axis after t seconds have elapsed is given by the following equation. S of t equals t to the 4th minus 2t cubed minus 6t squared plus 9t. Again, this is a position equation. So it's asking you to find the velocity of the particle at time t. So basically it's asking me the first derivative, which would be 4t to the 3rd minus 6t squared minus 12t plus 9. Part B. Find the particle's velocity at t equals 1, 2, and 4 seconds. So basically I'm going to be substituting t with v of 1 v of 2 and v of 4. You can use the calculator to do that work, and you will get negative 5 inches per second here. This is v of 2 is negative 7 inches per second, and v of 4 is 121 inches per second. Part C, when is the particle at rest? A particle is at rest when your velocity is equal to 0. So I'm going to take my equation and set it equal to 0. And use your calculator to come up with the values. So it's going to be t equals 0.634 and t equals 2.367. Right? So it is at rest at these 2 points. Okay. Let me erase this. I'm going to do D here so that you can all see it. So D, when is the particle moving to the right? Moving to the right means when your velocity is greater than 0, right? That's right. So left is when velocity is less than 0 or is negative. So what do I do is I use my number line, my velocity number line, cap it at 0, and my two numbers that will go on this are 0.634 and 2.367, and I'm going to take a number from each interval and find out if it's positive or negative. So if I pick a number, let's say a half, if I pick, this is gonna be positive in this interval. Again, use your calculator to just substitute. You're substituting in this equation, my velocity equation, because it's a velocity number line. And if I pick a number, let's say 1, if I substitute in 1 here, I do end up with a negative number, and then this would be positive. Right? So basically it's moving right from 0 to 0.634 and left from, oh, right is another interval too, 2.367 to infinity, and it's moving left is from 2.634 to 2.367. Okay. Part E. It's asking us find the total distance traveled by the particle after t be careful, after t equals 5 seconds. So basically I am going to find the absolute value of displacement wherever I'm changing direction. So I'm going to do s of 5 minus s of 2.367, right? That's where it's changing direction, which we know it from above, plus, let me just erase this. It's the same way as saying what is the total distance traveled in 5 seconds. So s of 2.367 minus s of, I'm just looking at this number line to come up with it, like my 5 is here and I'm just checking what it is. Okay, so this would be a 0.634 and then plus, I'm going to do it here, plus absolute value of s of 0.634 minus s of 0. So substitute those numbers in, and what do I get is I get s of 5 was 270 minus negative 7.44613 plus negative 7.44613 minus 2.94615 plus this would be 2.94615 minus s of 0 is just 0. So when I add these up, I get 277.446 plus negative 2.946 plus negative 10.392. Absolute value, remember, is positive, so if you add up those numbers, it's 290 point. Again, you are rounding to 3 decimal places in this class. So that is your total distance traveled, inches. Part F, it's asking us find the acceleration of the particle at 4 seconds. So I'm going to do first find my acceleration function, which is the derivative of my velocity, which would be 12t squared minus 12t minus 12, right? And I want to find at 4, I'm just going to substitute in 4, which would be 2 squared is 4, 4 times 4 squared is 16, 16 times 12 is 192 minus, this would be 48 minus 12, which is 132 inches per second square. Number 15, the table below shows the velocity of a particle v of t at various times t as it moves along a straight line. So a velocity table is given to us and it's asking us the following questions. A says how many times does the particle change direction during the 12 seconds? So basically this is velocity. A particle changes direction is when it goes from positive to negative and negative to positive. So that's happening here and here. So it is 2 times, right? So 2 times when velocity changes sign. Part B, during what intervals is the particle speeding up and slowing down? Speeding up is when velocity and acceleration have same sign. Slowing down is when velocity and acceleration have opposite signs. Remember, your velocity is your y values and your acceleration is the slope. So we're going to first, let's find the slope here. Let's erase this. And I'm going to find the slope. So here from 0 to 1, my y values are increasing. So my acceleration is what? Positive. From 2 to negative 2, acceleration is negative. From negative, it's going down, right? So that's how I'm determining. It's basically from 6 to 8, my acceleration is again negative. And here, oh, sorry, it's positive, negative 7 to 4, right? And here, it's negative again. So now wherever my velocity is negative, velocity and acceleration have same signs, my speed is increasing. Velocity and acceleration have opposite signs, my speed is decreasing. So in this first interval, 0 to 1, they both have the same sign, so it's positive, so speeding up is from 0 to 1. Then where else? Over here, my velocity from 3 to 6, my velocity and acceleration both have same signs, they're both negative, so that's another place. And that's it. That's where those are the 2 intervals where it's speeding up, right? And my reasoning is velocity and acceleration have same sign, although we wrote it there. Now slowing down. It's slowing down from 8 to 12, that's when velocity and acceleration have opposite signs. Okay, part C. It's asking us to find what is the acceleration at t equals 7. So 7, if you look at the table, is not even there. It's right here, right? So we need to find the value that directly surrounds 7. So we can do is what? V of 8 minus V of 6 over 8 minus 6. So V of 8 is what? 4 minus negative 7 over 2, which is 11 over 2 feet per second square. So that's basically it. Let's try number 16. The position of a particle moving along the x-axis is given by s of t equals 2t cubed minus 9t squared, where s is measured in meters and t is measured in seconds. Find the average velocity during the first 5 seconds. So basically what average velocity is your rate of change of position, right? So I'm going to find s of 5 minus s of 0 over 5 minus 0, which would be, if I substitute in 5, I get 25 minus 0 over 5, which is 5 meters per second. B, find the instantaneous velocity at t equals 4. Instantaneous velocity is my, first I need to find my v of t, it's my first derivative. So v of t would be 6t squared minus 18t, right? And at 4, substitute in 4, I get 4 squared is 16 times 6 is 96 minus 18 times 6, 4 is 72, not 6. 96 minus 72 is 24 meters per second. Find the acceleration of the particle at t equals 4. Same thing, very similar thing I'm going to say. So first I need to find my acceleration, which would be 12t minus 18. Find a of 4, which would be 12 times 4 is 48 minus 18, which is 30 meters per second square. And part D, when is the particle speeding up and slowing down? So again, speeding up means when your velocity and acceleration have same signs, right? And slowing down, opposite signs. Velocity and acceleration have opposite signs. So I need to first make up my number lines, means I need to set my velocity equation equal to 0. So if I do 6t squared minus 18t equal to 0, factor out 6t, I'm left with t minus 3 equal to 0. So t is equal to 0 and t is equal to 3. I'm going to do my velocity number line here. I'm going to cap it at 0, right? And my other number is 3. I'm going to pick a number between 0 and 3, let's say 1. So that would be negative. And then pick a number greater than 3 would be positive. That's my velocity. I'm going to do the similar thing for acceleration, set it equal to 0. So a of t equal to, or let's just say 0 is equal to 12t minus 18. So t is equal to 3/2, right? So I'm going to do my velocity. I'm just going to try acceleration number line right under velocity. So this is 0, this is acceleration, and 3/2 is like 1.5, so it's going to be here. So I'm going to pick a number between 0 and 3/2, which is 1. So if I substitute in 1, I get a negative. And then if I pick a number greater than 1.5, which let's say 2, it's positive. So now let's compare. If from 0 to 1.5 or 3/2, they have same sign, so it is speeding up. So let's write this down. D, speeding up, is 0 to 3/2. And then what's happening from 3/2 to 3? It's slowing down because they have opposite signs. 3/2 to 3. And then from 3 onwards, they have the same sign, so it's again speeding up. 3 to infinity. Okay, so let's try the last question. It's asking, giving us a graph. The graph below shows the position of a particle that moves on a horizontal line from time from 0 to 6. When is the particle moving to the left, to the right? So again, this is not a velocity graph. This is a position graph. So be very careful with that, right? My particle is moving left when my velocity is less than 0, and this is when it's greater than 0. So I'm going to be basically looking at the slope of it. So it is going to be moving left wherever my slope is negative. So my slope is positive here. From 1 to 2, it really doesn't matter, it's at rest. From 2 to 3, it is negative, so it's moving left from, let's write this down. I'm going to do A here. Left from 2 to 3, right from, let's keep going, 0 to 1, right? 2 to 3, it's moving left. Then 3 to 5, my slope is constant, so really don't write that. And then from 5 to 6, it's again, slope is negative. But remember, we don't use the word slope in the explanation, so please make sure we write velocity, right? And it's moving left, so it is 5 to 6. Okay, spot B. What is the total distance traveled by the particle from 0 to 6? So basically, I'm going to go piece by piece, and I'm going to see what is the change in y happening. So here, from 0 to 1, I travel 2 units. Then from 1 to 2, there's no change. From 2 to 3, it would be, or 2.5, if I can say this is 2 and this is another 2, right? We're taking the absolute value. Then there's nothing happening from 3 to 5, and then from 5 to 6 I travel another. So if I add up these number, it is going to be 8 units, right? Or here it is actually centimeters, 8 centimeters. Part C. During what time or what times is the particle at rest? So particle is at rest when velocity is equal to 0. So where is my velocity equal to 0? When my slope is constant. So my slope is constant where? From 1 to 2 and from 3 to 5. So part C, it would be, it's at rest is when my velocity is equal to 0. So it is from 1 to 2 and from 3 to 5. Right? Again, I'm going to say it again. We do not use the word slope, but it helps us to find the answer. But we have to use the right terminology to answer in terms of velocity and acceleration. So that was C. Part D. What is the velocity of a particle at 2.5? So basically, think about it. 2.5 is like somewhere here, right? So if I was to find, this is a line, if I was to find the slope of this line, the slope of the line is constant. So can I not do the average rate of change between 2 and 3? So for part D, if I find S of 3 minus S of 2 over 3 minus 2, and that will give me my slope or my velocity of the particle at 2.5. So which would be S of 3 is what? Negative 2 minus S of 2 is what? 2 over 1. So negative 4. So it's negative 4 centimeters per second. Last part E. When is the particle speeding up and slowing down? So okay, remember that first of all, there are two things to look at. This is a question usually being asked if your velocity graph was given, right? Then only you could determine your acceleration. Here, this is your position graph. So basically, it would be none. It's not speeding up and slowing down, because if you look at your velocity from 0 to 1 is a constant, some number, right? What is the derivative of that number? It would be what? 0. So again, it can keep going on. So this would be just none, because, and my reason would be because A of t would be 0 all along. So finish up, review again, and if you have any questions, reach out to me. Good luck for your test.